Lesson: Case Studies in Iterative Prompt Development. Iterative prompt development is a crucial skill in the field of prompt engineering, particularly within the context of artificial intelligence and natural language processing systems. This lesson is designed to equip professionals with actionable insights, practical tools, frameworks, and step-by-step applications to enhance their proficiency in developing effective prompts iteratively. The process of iterative prompt development involves continuously refining prompts to achieve optimal performance from AI models, thus ensuring that they provide accurate, relevant, and context-specific responses. One of the foundational principles in iterative prompt development is understanding the importance of starting with a clear and concise prompt. The initial formulation of a prompt sets the stage for subsequent iterations, and it is essential to define the problem or task with precision. For instance, when developing a prompt for a language model to generate a summary of a scientific article, the initial prompt should include specific instructions about the length of the summary, the key points to cover, and any particular style or tone required. A well-crafted initial prompt serves as a benchmark against which subsequent iterations can be measured and refined. A practical framework that professionals can employ during iterative prompt development is the Plan, Do, Check, Act cycle. This framework, originally popularized in quality management practices, can be effectively adapted for prompt engineering. In the plan phase, the prompt engineer establishes clear objectives and criteria for the AI's output. This involves identifying the desired outcomes, potential challenges, and success metrics. For example, if the goal is to generate creative writing pieces, the criteria might include originality, coherence, and adherence to a particular genre. In the Do phase, the initial prompt is implemented, and the AI model generates responses. The prompt engineer then evaluates these responses during the Check phase, assessing them against the predefined criteria. This evaluation helps identify areas where the prompt may need refinement, such as clarifying ambiguous instructions or addressing any biases in the responses. The Act phase involves making the necessary modifications to the prompt based on the evaluation results, thus completing one iteration of the cycle. This iterative process continues until the desired level of performance is achieved. Real-world applications of iterative prompt development often reveal the nuances and complexities involved in refining prompts. A compelling case study can be found in the development of customer service chatbots, where the goal is to create prompts that guide the AI to provide accurate and helpful responses to user inquiries. Initial prompts might instruct the AI to ask clarifying questions when the user's query is vague. However, through iterative testing and feedback, it may become evident that the AI needs additional prompts to recognize specific keywords or phrases indicating common issues. By incorporating these insights, prompt engineers can refine the prompts to improve the chatbot's efficiency and user satisfaction. Another practical tool for iterative prompt development is the use of A/B testing, a method commonly employed in software development and marketing to compare two versions of a product. In the context of prompt engineering, A/B testing involves creating two different prompts for the same task and evaluating which one produces better results. For example, when developing a prompt for a language model to generate technical documentation, one version of the prompt might emphasize clarity and conciseness, while another focuses on including detailed explanations. By comparing the outputs, prompt engineers can determine which prompt yields more accurate and user-friendly documentation. A/B testing provides valuable data that informs the iterative refinement process, leading to more effective prompt designs. The importance of data-driven decision-making in iterative prompt development cannot be overstated. Leveraging analytics tools to monitor and analyze the performance of AI models in response to different prompts is essential for identifying patterns and trends. For instance, if an AI model consistently generates biased responses to certain prompts, analytics can help pinpoint the specific language or context that triggers these biases. Armed with this information, prompt engineers can iteratively adjust the prompts to mitigate bias and improve the fairness and inclusivity of the AI's outputs. Iterative prompt development also involves addressing real-world challenges, such as the dynamic nature of language and context. Language is constantly evolving, and prompts that were effective at one point may become outdated or less relevant over time. This necessitates continuous monitoring and updating of prompts to ensure their effectiveness. A practical approach to addressing this challenge is the integration of feedback loops, where users or stakeholders provide input on the AI's performance. This feedback is invaluable for identifying areas for improvement and ensuring that prompts remain aligned with current language trends and user expectations. Moreover, the iterative process benefits from collaboration and interdisciplinary insights. Engaging with experts from different fields, such as linguistics, psychology, and domain-specific knowledge, can enhance the richness and effectiveness of prompts. For example, when developing prompts for a medical AI system, collaboration with healthcare professionals can provide critical insights into the terminology and context required for accurate and reliable responses. This interdisciplinary approach fosters a comprehensive understanding of the task at hand and supports the development of prompts that are both technically sound and contextually relevant. In conclusion, iterative prompt development is a dynamic and multifaceted process that requires a strategic approach, practical tools, and a commitment to continuous improvement. By employing frameworks such as the PDCA cycle, leveraging A/B testing, and embracing data-driven decision-making, professionals can refine prompts to achieve optimal AI performance. Real-world case studies and examples underscore the importance of addressing challenges related to language evolution and context, while collaboration and feedback loops enrich the iterative process. As the field of prompt engineering continues to evolve, these strategies will remain essential for professionals seeking to enhance their proficiency and deliver impactful AI solutions.